Howdy, everybody. Today I want to talk a little bit about how we can reduce air pollution, how we can address it. We've been talking about it a little bit as we go throughout the unit, but there are a few more things I want to talk about as we wrap up that we haven't exactly talked about yet. Apologies in advance if you can hear something in the background. My downstairs neighbor is practicing the bass, and I think he's in some sort of Tool cover band. So if you hear some rumbling in the back, that's what's going on there. So there are three main ways that you can reduce air pollution. You can switch to alternative fuels, which is pretty straightforward. You can focus on conservation practices, like reducing fuel usage. And then there are also regulatory practices. So when we do use fuel, how can we regulate the fuel that we're using and reducing the air pollution? So I'm going to go through them one by one. The first two are pretty straightforward. So alternative fuels, if we reduce our reliance on fuels that produce air pollutants, that's going to reduce the amount of air pollutants. For example, wood and coal produce a lot of particulate matter. Coal also produces a lot of sulfur dioxide and nitrous oxide when you burn it. If we can move away from coal, even towards natural gas, which burns a lot cleaner, that's going to reduce air pollution. Will it reduce CO2 emissions? Not as much, but it will reduce air pollutants like NOx and SO2. That also goes for diesel and other fossil fuels. So moving towards alternative fuel sources, whether it's electric cars or renewable energy or solar panels, what have you. You can also change your behaviors and change the culture and society to be more conservation minded when thinking about the way we use these fuels. For example, don't drive your car as much, walk more, or take public transport, or carpool, right? Get more bang for your buck when you're using fuel, so that way if you were taking two of your friends to school with you, then that's two cars that are no longer on the road, that are no longer producing air pollutants. Another big thing that you can do is educate one another about the way that you consume fuel usage and, for example, idling your cars. Tell your friends about why idling cars is so dangerous, and then if they're waiting in the pickup zone to pick up their friend, just shut the car off and wait. It'll be much better that way in terms of air pollution. The big one, though, are regulatory practices, and these are the ones I want to spend a little bit more time on. In terms of legislation, we've been talking about the Clean Air Act all year, but a lot in this unit. Here are some cool photos. This is the initial signing of the Clean Air Act in 1960 by that's President Lyndon Johnson, and this is a 1990 amendment to the Clean Air Act being signed by Ronald Reagan. We've been talking about that, so you should be pretty familiar with the cap and trade and removing lead from gasoline, things like that. But I now want to spend some more time talking about the technological advancements that help us regulate the air pollution we produce. One of the most common is something called a catalytic converter, which was developed in the mid-70s and is in your car now if you have a modern-day car. And it's extremely important. It takes pollutants from the combustion reaction like carbon monoxide, nitrogen oxides, and hydrocarbons, or VOCs. And it traps them and chemically alters them, transforms them into much less harmful gases like nitrogen, carbon dioxide, and water. Is carbon dioxide great? No, but it's certainly less toxic to breathe than these, and it doesn't contribute towards smog formation. So catalytic converters are really, really important. They have like this honeycomb type mesh in the center that is lined with some precious metals like palladium and rhodium, which makes them a little bit expensive. But as these gases travel through this honeycomb, they interact with these precious metals and do all sorts of crazy chemical reactions to produce less harmful gases. Here's a picture of what it looks like in your car. They're a little bit different in every car, but the honeycomb thing is inside of there. At gas stations, they have these things called vapor recovery nozzles. They're, as far as I know, they're at every single gas station. So you probably just think of it as a gas station nozzle. But it has these little slots or holes in the tip that prevent gas fumes from escaping as much as they did before these were developed. So they help reduce the amount of VOCs that are emitted at the gas pump, but also reduce the chance of explosion due to leakages. Other developments, I'm gonna zoom in on coal plants because they produce a lot of the harmful air pollutants that we've been talking about, mainly sulfur dioxide and particulate matter, and they have developed, thanks to the Clean Air Act's restrictions, they have been forced to develop regulatory technology to reduce those air pollutants. I want to focus first on sulfur dioxide. They do a process called desulfurization, which is pretty simple and pretty self-explanatory. They desulfurize their emissions, reduce the amount of sulfur dioxide in it, which is going to have beneficial impacts on acid rain formation. And they do that using a couple different technologies: scrubbers, which I've already mentioned, and fluidized bed combustion, which I've already mentioned as well. I'll review them one more time because they might be a little bit complicated the first time you see them. So wet scrubbers are not sponges. I know that's what you're tempted to think, but it's not Scrub Daddy, although I had one of these in college, would highly recommend it. Wet scrubbers expose the exhaust fumes from burning coal. So the coal's in here, it's burning, it's heating up this water, which makes steam and turns a turbine. But the fumes from the actual burning of coal will get transported into the wet scrubber, and the wet scrubber exposes the fumes to a scrubbing solution, a liquid that has water and some sort of calcium compound in it that will help neutralize the SO2 and reduce the SO2 emissions. It's basically simulating acid rain inside this tank. That's great because that means out of the smokestack is mostly coming CO2 and water and maybe a little bit of sulfur and a little bit of nitrogen oxide, but not a lot. These are very, very efficient, like 99% efficient. There are some problems though because this liquid here is concentrated. It's got concentrated sulfur in it, which I'll talk about in a little bit, can have some detrimental impacts. Here's another diagram showing how a wet scrubber works. The contaminated gas from the coal burning comes in. It gets exposed to this scrubbing liquid, which has calcium in it, which reacts with the SO2 and strips the gas of its SO2, and then the cleaner, much cleaner gas is released. That scrubbing liquid, however, can cause some problems. Here are, briefly speaking, the pros are that the wet scrubbers, they remove gases. They also remove particulate matter. They're very compact, and they can handle really high temperatures. They're used all over the place. The cons, however, is that they can corrode, they're expensive, and the big one is that this waste fluid that is produced, that needs to go somewhere. And if they can't repurpose it, if they can't recycle it or treat it, they just dump it into these pools or these settling basins, and the coal ash and the SO2 that has been trapped in there can lead to the buildup of toxic substances such as heavy metals. Just to clarify, because I might have misspoken there, the SO2 itself is not a heavy metal, but the coal has heavy metals in it, and when those come through in the gas, those are also stripped out and end up in this liquid here. Heavy metals like mercury, arsenic, cadmium, lead, and so those things can build up in these basins over time, and if an ecosystem is exposed to toxic heavy metals, that's going to be very detrimental to their health. On the flip side are dry scrubbers. Not that different. It's pretty self-explanatory. Instead of using a scrubbing liquid, they use a scrubbing sort of powder. So that's why it's called dry, because there's no liquid involved. It's more common than wet scrubbers because it's a little bit cheaper. It's a little less effective, but it doesn't use a scrubbing liquid, which means that it doesn't produce that scrubbing liquid waste. It does produce a residual powder, which is still dangerous, but there's a lot less of it, and it's a lot easier to dispose of. So that's it for scrubbers. The next one I mentioned before is fluidized bed combustion. Again, they're combusting coal. They're doing two things. One, they're combusting coal in the presence of pure oxygen, which increases the efficiency of the combustion reaction, which means that the pollutants produced are more concentrated and easier to trap. But it also burns coal in the presence of limestone or calcium carbonate. Limestone, we've talked about before, except we just called it lime, and that can be used in your soil to reduce the acidity. And it's very similar to the solutions that are used the chemicals that are used in the scrubbing solution in the wet scrubber. This is very similar to limestone. So by burning the coal with the limestone or the calcium carbonate, that's going to extract the SO2 at a very concentrated rate, so the gas that is released is much cleaner. So that's great. It's important to know, though, if the basics of what you need to know is that wet scrubbers, dry scrubbers, and fluidized bed combustion remove SO2 from the exhaust gas. They can also remove particulate matter, but mostly SO2. But Mr. P, how do they remove their particulate matter? Great question, Dora. It's so good to see you wearing protective gear again. If you don't appreciate this joke, I just want you to know it took me a long time to find an image of her in science-related clothing, and then I had to crop this all out, so please appreciate me a little bit more. I'm trying here. All right, I mentioned that these technologies can remove particulate matter, but mostly they focus on sulfur dioxide. So how do they remove particulate matter? They can use a couple of different approaches. One is something called electrostatic precipitators. You don't really need to know how it works too much. All you need to know really is that it uses a static charge, much like if you rub your feet on the rug and then touch something metal, you'll get a static shock. It uses that same phenomenon to trap particulate matter like dust and smoke and ash and collect them underneath. That's it. They collect particulate matter. And here's another image showing the electrical charge using to extract solid particulates from the gas as they move through this electrical, what's the term? Electrical gradient, I suppose? Yeah, sure. Let's go with that. And the last one are something called baghouse filters. No, it's not this, although it is very hilarious, and I know you're laughing your butts off right now watching this video, so thanks. God, I try so hard. Baghouse filters are just like really high quality filters that coal power plants use to extract nearly 100% of all particulate matter from their exhaust. So these technological advancements, both the electrostatic precipitators and the baghouse filters, do a great job at removing particulate matter from coal power plant exhaust. Meanwhile, if you want to remove some SO2, you have to use something like fluidized bed combustion, dry scrubbers, or wet scrubbers. And that's it. If you've got any questions about this, please bring them to the class as usual, and I'll see you next time. Bye.